section number 5 is talking about powers or sign numbers. Now, powers of sign numbers. First, I'm going to talk about the following. Suppose you're multiplying an even number of negative numbers. Now, an even number of things, whether they're negative numbers or basketballs, you can put them in pairs. That is, you can always group them in two. And so on, but all even. You pair them up. And the so on is just possibly some more pairs of even numbers. So there are not just 8 even numbers. There might 8 even plus signs. There might be 2 or 4 or 6 or 8. That's what this 3 dots mean. Well, like I'm pretty sure I said, but maybe in the end I stopped saying it because I read what I wrote. You have an even number of negative numbers, even number of negative signs. You can put them in pairs. A negative times a negative, negative times negative, negative times negative, negative times negative. Well, negative times negative is positive, times another positive, times possibly more positives, positive, positive. Well, you multiply a string of positive numbers, you get a positive. When you multiply an even number of negative numbers, you're going to get a positive. If you're multiplying an even number of negative numbers, you will get a positive answer. Now, every odd number can be realized or thought of as an even number plus 1. Every odd number is an even number plus 1. Every odd number, 103, is the number before, which is even, plus 1. Every odd number can be realized as an even number plus 1. So now, what if you have an odd number of negative numbers, which are being multiplied? You have an odd number. That's an even number plus 1. So you have an even number of negative signs, negative numbers, which you can put in pairs, and then you have one all by itself. Well, the negative times the negative is positive, times the negative is positive, times some more positives, because they're in pairs. I'm telling you what's in the so on is pairs of negative numbers, and a negative times a negative is positive, times the last negative. Well, when you multiply a string of positive numbers, you get a positive answer. Think about before you even heard the word positive number. When you multiply 7 times 2, you got 14. Everything was positive, you learned later on. You never multiply 2 positive numbers. You never said, well, 3 times 7 is negative 21. You never said that. You never even heard of a negative number. 3 times 7 was 21. And then you learned that 3 is called or considered a positive number, 7 is a positive number, and the result, 21, is also a positive number. When you multiply positive numbers, you get a positive answer times that lone negative. A positive times a negative is negative. When you multiply an odd number of negative numbers, the answer is negative. When you multiply an even number of negative numbers, the answer is positive. When you multiply an even number of negative numbers, the result is positive. When you multiply an odd number of negative numbers, the result is negative. You definitely should know this theorem. When you multiply an odd number of negative numbers, the result is negative. When you multiply an odd number of negative numbers, the result is negative. That way you don't have to say, if you have to multiply 5 negative numbers, negative 2 times negative 3 times negative 4 times negative 2 times negative 3. You don't have to say, well, let me do the sign first. A negative times a negative is a positive. So now a positive. A positive times a negative is negative. So the answer so far is negative. Times another negative is positive. Times another negative, the answer is negative. Now, you don't have to do it that way. You can say 1, 2, 3, 4, 5 negative numbers. That's an odd number. 5 is odd. So the answer is negative. And then you can say 2 times 3 is 6, times 4 is 24, times 2 is 48, times 3, 48 times 3 is 144. Now, so it's negative 144. You don't have to bother saying a negative times a negative is this, times another negative is that, times a fourth negative times a fifth negative. Just say 5 negatives, that's an odd number of negative signs, so the answer is negative. Now, while we're at it, let's see that if you plug in or stick in some positive numbers, it won't affect it. That is, if you have 5 negative numbers and you have some positives, positive, 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 the answer will still be negative. The reason is, if you multiply a number by a positive, regardless of what you have here, a negative times a positive, multiplying by the positive didn't do anything. It's a negative. If you take a negative number and you multiply it by a positive, you get back what you started with, positive. Multiplying by a positive number doesn't do anything. Okay, that is, you can just say 1, 2, 3, 4, 5 negatives. 5 is an odd number, the answer is negative. If you had 6 negatives, which is a positive number, the answer is positive. Sticking in these positive signs didn't do anything. A negative times a positive is still negative. If that plus wasn't there, you already had a negative. And a negative times a negative is a positive. Multiplying by a positive still gives you positive. That is, you can just use this. Multiply by positive, it's still positive. Multiply this by a negative, it's negative. So up to here, the answer is negative. Multiply by positive, it's still negative. It is, multiplying by positive didn't do anything. Multiply a negative, it was negative. By another negative, the answer is positive. Multiply by another negative, it's negative. Up to here, the answer is negative. Multiply by a positive won't do anything. The answer is still negative. Times another negative will make it positive. Multiplying by positive numbers do not affect what the sign was before. If you're negative 3, negative, and you multiply by a positive 2, if you're negative and you multiply by a positive, it didn't change anything. You still have negative. And 3 times 2 is 6. Alright. Now, what does all this have to do with powers? Well, the last thing about sticking a negative sign, positive sign, really didn't have anything to do. But you needed to see it. if you have a negative 7 to the 3, here are powers. Powers assign numbers. Well, you're going to be multiplying a number by itself 3 times. That is, you're going to be multiplying 3 numbers. And they're all negative. Negative, negative, negative. The answer is negative because 3 is an odd number. You're going to have an odd number of negative signs. So you don't even really have to do this. You can say it's a negative number and I'm multiplying it by itself 3 times. That is, I'm multiplying 3 negative numbers. That's an odd, 3 is an odd number. So the answer is negative. And you should know that 7 times 7 is 49. Times the third 7, you should know that 49 times 7 is 343. 49 is 50 minus 1. 7 times 49. 7 times 50 is 350 minus 7, 343. So the answer is negative 343. Somebody asked you, what is negative 5 to the 4th power? Well, it's a negative number times a negative number 4 times. It's an even number. The answer is positive. The question is, what is 5? So now we did the sign. Now we just do the number. Notice I'm not writing down any signs anymore. I already know the final result of the sign. It's positive. 5 times 5 is 25. Times another 25. You don't have to do 25 times 5. And then that number, 125, times another 5. Just do 25 times 25. If you don't know it, you do it on the side. But you really should know it. It's 625. So the final answer is positive 625. Of course, you can just have written 625. You don't have to say the positive. There's no sign. If there's no sign, like over here, it's understood to be positive. So if you have a negative number being raised to a power, if the power is even, the answer will be positive. If the power is odd, the answer will be negative. If you have a positive number raised to an exponent, the answer is always going to be positive. You got 4 cubed. 4 times 4 is 16, times 4 is 64. And understood, positive 4 times itself 3 times. That is positive times positive times positive. That's positive. Negative 2 cubed. Well, it's a negative number. Multiplied by itself 3 times. That is, we're multiplying 3 negative numbers. They happen to be the same number, but that doesn't matter. We're multiplying 3 negative numbers. 3 is odd. Answer is negative. 2 cubed. 2 times 2 times 2. Why, that's 8. The answer is negative 8. Now, this number is 81 with a negative sign in front of it. Hence, negative 81. This number is this number is 84 with a negative sign in front of it. Negative 84. 2 cubed is 8. 2 cubed is 8. This is 8 with a negative sign in front of it. That makes it negative 8. Let's consider these 2 problems. The base here is 2. 2 is being raised to the 4th power. 4 times 4, 16. With a good old negative sign in front of it. That's negative 16. Here, because of the brackets, negative 2 is the base. This means negative 2 4 times being multiplied. signs, namely 4 of them, the answer is positive. 2 times 2 is 4, times another 4, the answer is 16. They're not the same answer. Now, I'm sure that if somebody asked you what 20 minus 2 to the 4th is, you would say 20 minus, not plus. Minus, you would say 16. The reason you're saying minus 16 is because negative 2 to the 4th is negative 16. Now, you even know that. So, I advise you to know it up here as well. It's going to make you happier when somebody asks you what that is. Say, oh my, I don't like that problem. Fine, don't like it. Put a 0 in front. That's like putting the 20 in front that I did over here. So it's 0 minus 16. 16 minus 0 is 16. If I read it backwards, my sign was wrong. It's negative 16. Okay, negative 2 to the 4th is negative 16. It may sound the same, but it's written differently. Negative 2 to the 4th is 16. They give you different answers. Now, when you come upon problems like that, you want to hope that the exponent is negative. If you have, say, negative 4 to the 3 versus negative 4 to the 3. That's the number that has the minus sign in front of it. 4 cubed happens to be 64. What's the minus sign in front of it? 4 cubed is 64. Somebody goes and put a negative sign in front of it, well then negative 4 cubed is negative 64. Now here, you have a negative number being, so the negative 4 is being raised to the 3rd power. Unlike in the last problem, where only 4 was being raised to the 3rd power. You have a negative number being raised to an odd power. That's negative. And 4 cubed is 64. So here we got the same answer. Now, if the student were to write that this is equal to negative 4 times negative 4 times negative 4, which is negative times negative times negative is negative, and 4 times 4 is 16, times 4 is 64. I couldn't mark this student wrong, because this is negative 64, and so is this. So here they're equal. And this is negative 64, and that is negative 64, so they're equal. There's nothing that's really wrong here. However, the meaning of this is not negative 4 times negative 4 times negative 4. But since they're equal, I couldn't mark the student wrong. The meaning of negative 4 in brackets cubed is negative 4 times negative 4 times negative 4. What am I really trying to say? If the exponent is negative, you can actually think of it wrong and still get the right answer. Negative 4 cubed does not mean what's in the box. Does not mean it. But fortunately, possibly for you, they're equal. So it couldn't be marked wrong. If your teacher marked it wrong, you ask your teacher 3 questions. I think it's 3. Yeah, 3 questions. I guess 4 questions. How much is this? The teacher's going to say negative 64. How much is this? The teacher should say negative 54. And they're equal, aren't they? Yeah. And what does this say? Negative 64. They're equal. What is wrong? And you tied your teacher's hands. There's nothing that you wrote that's incorrect. It's like saying, one might want to know why you do this, but 4 times 3 is 2 plus 2 plus 2 6 times, which is 12. There's nothing wrong. I would wonder why you're thinking of this as that, but there's nothing wrong. 2 squared, that really means 2 times 2. If a student wrote 2 plus 2, I would assume that they would think 4 to the 5th means 4 plus 5 maybe. Or 4 plus 4 5 times, which is wrong. That is, the logic is wrong here, but they're getting the right answer. It shouldn't be marked wrong. But enough of that. Okay, the power is odd. You can be sloppy and think the minus sign is inside the brackets or outside of the brackets. It doesn't matter. But when the sign is even, it definitely matters whether that negative sign is inside the bracket, like -4 cubed, even. This will be 16. Or if you have 4 squared, which is 16, with a negative sign in front of it. Okay, then it really matters. Okay, what about this silliness? We know that -2 cubed is -8. So, this is -8. And when you put the minus sign in front of it, it's plus 8. Negative and -8 is plus 8. I'm sure most of you would agree with that. Negative and -8 is plus 8. If this number is -27. Somebody goes and puts a minus sign in front of it, well then you should get -27, which is positive 27. Now, you should know the 1 times table. For example, this is not 5. 1 times 1 is 1, times 1 is 1, times 1 is 1, times 1 is 1, which is 1. In fact, 1 to any power is 1. 1 to any power is 1. Okay, 1 to any power. You have 1, and maybe you couldn't read the number your teacher wrote down. It doesn't matter. You should say 1. Because this is the number. It's 11, it's 42, it's 19. Doesn't matter. 1 to that number is 1. So even if you couldn't read it, you know the answer. But what if the base is -1? And -1 to the 13. That is, you're going to be multiplying -1 times -1 13 times. That is, you're going to be multiplying a negative number by itself an odd number of times. That's negative. Do the sign first. It's negative. And then 1 to the 13 is 13. The final answer is -13. You have -1 to the 24, while a negative number times itself an even number of times is positive. And 1 to the 24 is 1. Let me go back to the last problem. 1 to the 13 is not 13. 1 to the 13 is 1. 1 to the 24 is 1. In our case, positive 1. Of course, you can just write down 1. You have -1 to an odd power, a negative to an odd number is negative, and 1 to any power, including 83, is 1. So the answer is -1. You have -1 to an even power, a negative times itself 14 times. That's positive. I won't write the positive sign. And 1 to the 14 is 14. So, 1 to the 14 is 1. 1 to the 14 is 1. So, what I just puts a negative in front, well then you should get negative 1. This number is negative 1. Somebody puts a negative in front on the left side, you should do the same on the right side. It is now negative 1, which is positive 1. This mess is positive 1. If you say have 2 cubed, say, over 4, you can, since the top is not 2, 2 cubed is not 2. This is not 2. It isn't, it's 8. Okay, you cannot say, well, 2 goes into 2 one time, and 2 goes into 4 2 times. So then you have 1 cubed over 2, which is 1 over 2. That is not true. What I said verbally was true. 2 goes in here one time, and 2 goes into that number 2 times. What I said was true. However, this was not 2. It's not 2. 2 cubed means 2 times 2 times 2 over 4. Now, that number, that's 2. That's 2. And 2 goes into this top number one time, and 2 goes into that bottom number one time. You know what? That number is 2. 2 goes in here one time, 2 goes in here one time. The bottom is just 1. The rule for dividing by 1 is don't. What survives on top is 1 times 1, which is 1, times 2, which is 2. The final answer is 2. And this makes sense because 2 cubed is 8, divided by 4. 4 times 2 is 8. So yeah, 8 divided by 4 is 2. 2 cubed divided by 4 is 2. Okay, since this number is not 2, you can't say 2 goes into 2 one time. What you're saying is that 2 goes into 2 cubed 1 cube times 1 time. That's not true. This is really 8, and this is 1. 2 doesn't go into 8 one time. 2 does not go into 8 one time. So you need to be careful with that. Now, if you say have 2 to the 4th cubed, this does mean 2 over 4 times 2 over 4 times 2 over 4. And if you multiply the tops, 2 times 2 times 2, you know what? For right now, let's make this 41. So you do get 2 cubed on the top, and 41, the bottoms. 41 times 41 times 41 is 41 cubed. In fact, if you have a over b, all of it raised to a power, say n. It's the top raised to that same power divided by the bottom to that power. That is, if somebody asks you what 2/3 cubed is, you can think what's 2 cubed, which is 8, and what is 3 cubed? Oh, that's 27, and there's your answer. There's your answer. Now, the question now is, can you reduce what's inside the brackets if it's all being raised to a power? If you have, say, 2 over 4, say to the 3rd power. Well, this means 2 over 4 times 2 over 4 times 2 over 4. Now, if 2 over 4 can be reduced, it can be reduced. Here, here, and here. You should get the same answer. And 2 goes into both of these numbers 1 and 2 times. Into here, 1 and 2 times. 2 goes into the top 1 time and the bottom 1 time. And now you're repeatedly multiplying a half 3 times. So we just learned that 2 quarters, say to the 3rd power, is a half to the 3rd power. And then you say, oh my, 2 over 4 is a half. And you can reduce first. You have 1 cubed over 2 cubed. 1 cubed is easy, it's 1. 2 cubed is 8. Okay, rather than saying 2 to the 4th cubed is 2 cubed, which is 8, over 4 cubed, which is a much bigger number, and then say, oh, 8, fairly large number, goes into both of these 1 and 8 times, and the answer is an 8. All I did was cube 1 and cube 2. When I had a cube 2 here, I had a cube 2 in both cases. Because here I cubed 4 and here I cubed 1. And after cubing the 1 and the 4, I had to reduce here, and here I didn't. Reduce first. Okay, reduce first. If you have 6 over 3 cubed, you can do 6 cubed over 3 cubed. 6 cubed, I think, is 216. 3 cubed is 27. Now you have to figure out how many times 27 goes into 216. Normally, I have no idea, but today I know it's 8. You know why? Because that's 2. 6 over 3 is 2. And when I cube it, I'm supposed to get 8. And if I don't reduce it first, in the end, I'm supposed to get the same answer. So I knew the answer would be. But you're going to have to be 27 times 5, or that's 135. 27 times 9 is 243. That's too much. It's above 216. 27 times 8, 56. Oh, there it is. It's 8. All I did was cube 2. Reduce first. Again, if you have 6 over 3, all cubed, you can say, oh, 6 over 3 is 2. And then cube that and get 8. Sometimes, when you reduce, it may not become an integer. But nonetheless, you'll get smaller numbers. So nonetheless, you should reduce. Like if you have 8 over 6, and you want to cube this. Actually, I don't know what 8 cubed is. 8 times 8 is 64 times another 8. Looks like 512. 512. So I get 512 over 6 cubed, which is 216. Now I have to reduce that. And these numbers are a lot bigger than 8 and 6. If I reduce 8 over 6 to 4/3, I divide the top by 4, by 2, and the bottom by 2. Well, now I get 4 cubed, which I know, over 3 cubed. It turns out that 8 goes into both of these numbers. 64 times and 27 times. How many of you know that? Reduce first. 8 over 6 is 4 over 3. And one last comment that I want to state a second time is that before you reduce, everything has to be in the brackets. Everything has to be in the parentheses, brackets, whatever you prefer to call those things. You call them brackets, curly brackets, parentheses, they're all the same. If you have 6 squared over 3, you cannot divide the 6 into 3. Why? Because that's not 6. That's not 6. It's 6 times 6. over 3. Now, you can say it's 36 over 3, and 3 goes into 36 12 times. But that might be hard for you, which is fine. 6 squared means 6 times 6 over 3, and 3 goes into the 6 2 times. Oh good, I know what 2 times 6 is. Okay, sometimes you don't want to figure out what 6 squared is, because this 3 is going to go in. Okay, sometimes you wouldn't want to do that. What if you had 6 squared over 3 cubed? I mean, you can say, well, 6 squared is 36 and 3 cubed is 27. But you should know that this 3 is in the bottom. Some of the 3 is in the, you should know 3 goes into 6. This 3 goes into 6 2 times. This 3 goes into the 6 2 times. And this 3 doesn't go into 2 nor 2. 2 times 2 is 4. The bottom is 3. The answer is that. Now you'd have to know your 9 times table to proceed like we did to the left. You'd have to know 9 goes in here 4 times and 9 goes in there 3 times. That is, if somebody asked me what this equals, I would not say 36 over 27 and then reduce. 9 goes in here 4 times, 9 goes in there 3 times, 4/3. That's way too complicated. Somebody asked me what 6 squared over 3 cubed was. I would write it down as 6 times 6 for the top, 3 times 3 times 3 for the bottom. 3 goes into 6 2 times. 3 goes into 6 2 times. 2 times 2, which is 4 over 3. Now, I did it that way because I knew that, other than 1, there were numbers that would go into 3 and 6, namely 3. But if that wasn't going to happen, if I had 7 squared over 2 cubed, the only number that goes into 2, other than 1, the only number that goes into 2 is 2. But 2 doesn't go into 7. Then I would just say that's 49 over 8. Because 7 is 7 times 7, and 2 cubed is this, and I can't reduce. So I'm going to ask myself, what's 7 times 7? But that's exactly what that is. And down here, I'm going to ask myself, what's 2 times 2 times 2? But that's exactly what that is. Okay, you need to know your times table. You need to know what number goes into 2, what number goes into 7. The only number that goes into both of them is 1. And you don't want to divide by 1. 1 goes into 2 2 times, 1 goes into 7 7 times. 1 goes into 2 2 times, 1 goes into 7 7 times. 1 goes into 2 2 times, 1 goes into 7 7 times. Couple of comments. This goes on forever, and you didn't really get anywhere. You still have 7 times 7 in the bottom, on the top, and in the bottom you have 2 times 2 times 2. You're not getting anywhere dividing by 1. So if you see that there are numbers that go into 3 and 6, then write it out this way and carry out that reduction. Okay, this ends the section on powers of signed numbers.